Hey everyone, welcome to another Corona tutorial, and today we are going to look at the new improved PBR shading in Corona 1.5. So when most of you, I guess, hear the term PBR shading, the first thing that comes to your mind is either improved compatibility with PBR standardized maps that come, for example, from Substance Painter, so you get one-to-one result in Corona as with what you see in Substance Painter, or some of you may think about resolution of the problem where highly reflective materials with low glossiness would kind of light up on the edges, create these bright outlines. But in fact, the main big thing that the PBR shading is very simplified workflow of material setup. So previously, if I'm sure many of you saw the previous tutorial on material creation, where we've been creating a lot of different materials, and there was basically a rule that the rougher material is like concrete or like old worn wood, it would have usually lower reflection value, so the reflection level wouldn't be as high, or reflection color wouldn't be as high, and the Fresnel IOR would become higher. This rule was to mainly to reproduce effect where on the materials that are a bit rougher, the reflection difference between facing angle and the parallel angle is usually a bit less. There's a bit less contrast in the reflection amount between these two angles, and the reflection is generally dimmer. And there would be this gradient of the rules of thumb on which settings you should apply to which material. With PBR shading, this is a lot simpler. You can apply a quite simple rule to vast majority of the materials. So in order to successfully start shading your materials with PBR, you need to kind of divide them into three categories. The first category would be transparent dielectrics and liquids. The second category would be the opaque dielectrics, and the third category would be metals. And once you establish in which of these three categories your material belongs to, then you can very simply choose the way in which you should set up your material. So basically, the reason why we divide materials into these three categories is to get right Fresnel IOR, or in the case of first category, also the refraction IOR. So the first category, which is transparent dielectrics and liquids, the best way to get IOR for these is to find some table like this. This took just a few seconds of Googling some IOR table, and you will see the different kind of IOR settings for all sorts of materials. So here we see, for example, that water at 20 degrees Celsius is usually about 1.33. And the reason why this is important, especially for this category, is because we do not see only the reflection, which doesn't change that much with the change of the Fresnel IOR. The change is a bit more subtle. The refraction, though, their changing of the refractive IOR makes a more significant difference. So that's why for the transparent materials, we should first of all try to find the correct IOR. Then for the opaque dielectrics, this is a lot simpler because if we take a look at most of the opaque materials, you can see they simply range somewhere around 1.5 of the Fresnel IOR. So you can see if you had to apply a rule of thumb to all of the opaque materials that are non-metals, then you would basically arrive at about 1.5, 1.6 such value. So we can generalize this and just use pretty much 1.5 for almost every material. And then there are metals, and metals usually have 0 to none Fresnel fall-off, so there you can just, you know, increase reflection all the way to 1 and set Fresnel all the way to maximum. And then you can either keep it like this, or you can plug maybe complex Fresnel texture as the reflection color, which will give you even more accurate results. But the main difference why we couldn't do this before and why we can do this now is because the PBR mode. Let's add new material. If I decrease the brightness and increase the reflection, let's decrease also the glossiness so we can see the change right ahead. If we go here and disable the PBR mode, you can immediately see this white fringe appearing. And what basically the PBR mode does is it alters the reflection intensity of on the grazing angles according to the glossiness of the material. So the glossier the material is, also the darker the reflection becomes. And once this is established, then it means that for every single material that is opaque dielectric, that means it is not transparent and it is not metal, what you can do is always, in 100% of the cases, keep the reflection color to complete white. You do not need to change it in any way. And you can keep this Fresnel IOR at 1.6, again in 99% of the time. And all you really need to care about is your glossiness value or your glossiness map. So if we put this into practice, let's start making materials. Let's make some simple wood. So let's go to the textures, find wood, some fine wood, and let's try, for example, this one. So this is generic material, maximum reflection, 1.6 Fresnel IOR, so I will just put this in the diffuse slot. Make sure our reflection level is at 1, of course. And I will use a modified version of this map also as the reflection glossiness. Maybe decrease the contrast of the map just a little bit. And you can see we have really nice looking wood material that looks really kind of almost, you can touch it and feel the wood, with just this completely easy setup where you don't mind almost anything. You only thing you care about is basically getting your textures right. Whereas if we disabled the PBR mode, it doesn't only modify the fall off of the reflection, it also modifies the glossiness, because that was another thing we had to do in order to make the materials PBR compatible. But just so we have some fair comparison, I will have to copy this, add it, and then once I disable the PBR mode, it will become a lot more glossy, so I will have to compensate for that. So let's see, this is still too shiny. Okay, this looks a bit close. Now you can see this difference where this looks really realistic as you would expect the wood to look. And here let's maybe add also output map to the diffuse and make it a bit darker so we can see the difference a bit more. So this is the old model and this is the new model. And with the old model, you can see every material would kind of fade away in this generic hard glass-like surface. Whereas with the new model, it keeps the material structure believable and the same across all the angles. So again, you can see we didn't really do any guessing of this value or of the reflectivity. All we care about is the right glossiness map. So again, if I try to make, for example, plastic, I will put in on this material. I will make it like red, dark red plastic, set the reflection to 1, and this to 1.6. And again, as I decrease the glossiness, you can see the material remains believable. So let's say it's like not completely shiny plastic, and let's add some structure like this, for example, into reflection glossiness. And we can see we have nice material right out of the box. Let's maybe modify the map slightly. And let's try to add a little bit of subsurface scattering. So go here, first turn off the opacity, let's set up density of our scattering. Let's make this like this reddish color. Okay, opacity back to 1, introduce translucency. And let's make this material a bit more rough. Okay. Now we can see it looks quite soft, almost like a rubber. And again, if I go here and disable the PBR mode, and if I were to compensate for the loss of or the increase of glossiness, you can see again it doesn't look really that natural. It looks more like it's fading again to this generic hard material instead of keeping its properties all the way across all angles. So if I plug this one back in and enable the PBR mode, you can see this material looks a lot more softer, looks a lot more natural. So again, this applies to pretty much every kind of material. Even if you had something really rough, like let's say rough concrete. So let's get concrete, like this one, edit, maybe make it a bit darker. Even in this case, you can apply the same rule, or reflection all the way to 1, reflection color white, again 1.6, and all you care about is getting nice reflection glossiness color. If I turn off diffuse here and set the diffuse color to complete black, you can clearly see how the reflection glossiness affects not only the glossiness itself, but also how much the material is reflective. So as I go down, you can see it also darkens. And this is exactly what we want, because when you see rough concrete, it doesn't look very reflective. Yet we are using the same highly reflective color and Fresnel as for the other materials. So the guesswork here is extremely simple. Let's again turn it back on. We would use bump for this as well. And that is it, and we have nice concrete. So this applies to pretty much any material you want, be it paper, be it plastic or wood, or I don't know, even painted metal, as long as there is a coat of paint on the metal. Pretty much ceramics, paper, leaves, anything. as long as it's not transparent dielectric or liquid like water, glass or anything like that, and as long as it's not metal. When it is metal, what you do is you create your material, set diffuse to 0, metals have no diffuse, set reflection to 1, in the same way you set here, always reflection to 1. But here you set Fresnel IOR to maximal value. And again, all you really care about in this case is your reflection glossiness map. So let's put this into reflection glossiness. And you can see the glossiness is really low. And as I increase it, you can see it starts to look more metal-like. And of course, in case of metals, you can always tint the reflection color. For the non-metals, reflection color is always white. And here we have some kind of gold. So once we have this established, the way we do the metals, the non-metals, and of course the transparent materials where, you know, this would be, for example, water. Transparent materials should always have these two IOR values the same. Once we have established this rule, it doesn't mean that you cannot have any artistic controls over your materials. Now, if you use this workflow, then this single value becomes your artistic control. And this is in a way that, let's say you create your wood material using this simple approach, and then you just look at a photo or at your material in real life, and you feel like, this looks a bit more reflective than it looks on my render, or it looks a little bit less reflective. So then simply use this value to artistically fine-tune your material. If it looks less reflective in the real world, then just decrease this value and you will dim the reflection, but you will keep all the relationships that are going on in there intact. If it looks a bit more reflective on your reference photo or in the real world, then you again increase this value and the material becomes shiny, but again keeping all the relationships that the glossy Fresnel will take care of for you. It will keep them intact. So this is the way you can, in the artistic manner, control this setup. So just more reflective or less reflective means higher or lower IOR. For the metals, again, technically they should have all maximum IOR, but let's put this back to white. Let's say your chrome, for example, like scratched chrome, let's make that material now. So, or like brushed steel. Okay, let's make something like brushed steel, which would mean that's too dirty looking. Okay, let's say you find the appearance of the metal in the real world on the photo reference to be kind of deeper, darker feeling metal. Then you again can decrease the Fresnel IOR, and the more you decrease it, the more contrasty and darker will your metal material appear. So again, for the metal material, you can start with the maximum value, but if you feel like your metal is too dull and doesn't have contrast, then aside from, of course, playing with the glossiness, you need to have this, you always need to get this right first. You can always decrease the Fresnel IOR to get deeper, more contrasty metal. So yeah, this is it. This is how you now can in a more easy manner set up materials in Corona 1.5. Again, for everything that's not metal and non-transparent, this is white, this is 1.6, and you can tweak it later on, and all it really matters is getting glossiness right. Same applies here, except this should be out of the box, or on your first attempt you should set it to maximum, and then you can get the glossiness map right. And if it doesn't feel right, you can always just use this for your artistic control, the Fresnel IOR. And as we talk, for the transparent materials, you just use the table. And even for transparent materials like the glass, again, let's quickly make glass. Here, let's say, for example, you have some windows that you want more reflective. Again, you can employ the artistic control here and increase this to 2 or 3 to make your glass more or less reflective for the artistic control. So yeah, that's really all there is to it. I would like to say big thanks to Untitled Chapter, who has been a big proponent of this solution, and who was very convincing in persuading Corona developers to implement it. And he was also the one who came up with a really comprehensive, simple explanation how to apply this rule in the practice. And he had this quote where he said, now you can finally focus mainly on getting your texture right, on making some nice textures. Because no matter how great your material setup is, if your textures do not look right, then the material itself won't save it. So now you have very simple rules to set up your materials, and if you combine them with very well crafted textures, your materials are going to look really amazing, and you do not have to have much of expertise in material setup or experience in material setup. You can be a new artist who's good at artistic side of the things, not very good at technical side of the things. And if you create yourself some nice texture and apply these simple rules, your materials will always look great. So I really do hope you found this useful, and I'll see you next time. Goodbye.